So today I had the amazing opportunity to speak with one of the legends in the blockchain space, Charles Hoskinson. He's been involved with a number of different projects you've heard of, including BitShares, Ethereum. Apparently he was a Bitcoin educator even before all that. And so what we talked about, though, is his newest project called Cardano. And he is a much smarter man than I, so I will let him take over and explain to you all about what Cardano is. So thanks for being on today, Charles. And we're here to talk about Cardano. So Cardano, it's not a cryptocurrency per se. It's more than that. It's more than just smart contracts. It's really a whole platform. I would like to hear in your own words, though, kind of the elevator pitch, maybe the 30-second version of what Cardano is.
Okay, so Cardano is basically an aggregation of a bunch of protocols that together act as our best bet for what a third-generation cryptocurrency needs to look like. So what is a third-generation cryptocurrency? It's basically a cryptocurrency that can do all the things that we love with Ethereum and Bitcoin, but at a scale of billions of people. A cryptocurrency that's capable of talking to many other cryptocurrencies and legacy financial systems, and a cryptocurrency that's able to sustain itself, meaning it can pay for its development long term. And also there's some sort of methodology to decide how a cryptocurrency needs to top grade. So basically Cardano's our best vision of how to achieve scalability, interoperability, and sustainability while preserving all the features that people have come to know and love with Ethereum and Bitcoin, and then extending those features to new and even better experiences.
Okay, great. So I guess that's a good segue. So how is that done? How can you pack a bunch of transactions into a small amount of time?
Okay, you broke up a little bit at the tail end of the question, but I think the question is how are we capable of doing such a thing? So the first thing that you have to do is you have to start separating concepts, because it turns out that when you go beyond just dumb everyday transactions and you go into computation, that computation has different demands. First off, while the quality and fidelity of the books of the system are everybody's concern, your poker game or your particular CryptoKitties app is not really the concern of the entire network. It's the concern of just the people involved. And what you're relying on the network to do is to provide you things like auditability and timestamping and verified computation. But these are services, and these are not necessarily services that everybody ought to care about in all situations. So the first thing that we do with Cardano is we separate accounting from computation. And we do that by creating two distinct systems, two distinct blockchains. One is called Cardano Settlement Layer, and the other is called Cardano Control Layer or Computation Layer. And basically, one is where the assets live, ADA lives, and other user-issued assets and so forth. And the other via a sidechain is the kind of computation domain that's specific to a particular grouping of demands. Now, once you've done that, then you can have different computational models, and they can be targeted towards different use cases. So one, for example, can be an Ethereum compatibility model, and two can be for high assurance applications, and three can be for maximizing interoperability. So that's kind of the first step. The second step is saying, well, how do we get high throughput? How do we get lots of transactions? How do we actually achieve scale with billions of people? So conceptually, the easiest way of thinking about that is saying that we need a system that when people join the system gains resources. If it's a sum zero deal where as you gain people, you have less of the pie for everybody, no matter how big that pie is, eventually you'll outgrow it. It'll just get too large. So if it's 10,000 per second for TPS, well, then what happens when you need a 10,001? Then you have to figure out a way to make that a ceiling go. So much rather, you'd like to have a protocol like BitTorrent, or when more people join, the faster it gets, the more capabilities, more resources you get. And that's a property if you decompose it into three different dimensions. One is raw transaction processing, two is network, and three is data. So you have to be able to gain more blockchain space as you get more people. You have to be able to move data in more efficient ways as you gain more people. And then you have to get more transaction processing power as you gain more people. So the first step is separate computation from accounting. The second step is find a way to make the network capabilities grow as you gain people. Now, if you do those two things, then you can scale to billions of users successfully, as BitTorrent has done.
Yeah, it's really interesting. So you mentioned, having separate blockchains for each of those things. Mm-hmm. One of the problems we're now seeing with some of the older cryptocurrencies and blockchain projects are that they've been around so long that their blockchains, just takes up a lot of storage space on your computer. So
Right.
having multiple blockchains seems like it would compound that problem. Are you guys doing anything to address that?
Yeah, so first off, a question of who needs to have the data and how much of the total chain do you need to have. So it's important to understand that the Bitcoin model of security, no matter who you are, is not sustainable in the long term. And that model of security is that everybody is a full node and everybody has a full copy of the blockchain. No matter how good you are at compressing things and finding ways of representing data in a very small form, you'll become a victim of your own success. Your blockchain's simply just going to get too big. It'll go from the gigabytes to the terabytes to the petabytes. And at some point, you can no longer store that on a consumer laptop. You can no longer store that on a consumer home computer, or even in an enterprise setting. You need like a big data center to be able to preserve all of that. That's just the nature of how this game works. So what you need to do instead is you need to say, how do I treat this kind of like a distributed file system or distributed database where no one node actually has a full copy of everything? And instead, we have assurances that when data shows up, we can verify that it's right, it's correct. BitTorrent works much like this. It has this idea of a distributed hash table. You would kind of have that. And then when people give you units and they say this is part of the file, you're able to verify that what they've given you is correct without having seen it before. So it becomes, instead of a storage problem, it becomes an availability problem. So this is something that you need to solve regardless if you have many blockchains, you have one blockchain, because at some point you'll become a victim of your own success. So how do we solve that? Well, the first step is to say that the interoperability problem and the storage problem are closely related to each other. And it conceptually, you have to think about that for a little bit. But basically what interoperability is all about is saying, I have a blockchain like Litecoin or Bitcoin, and I'm getting transactions from those blockchains. And I want to know if those transactions are real, meaning that the tokens that I'm receiving are legitimate and they haven't been double spent and so forth. Well, that requires you to have some idea of the history of that blockchain. But if the model is that you have to have the entire blockchain to be able to verify that, you've accomplished nothing. You'd like to have some sort of compression proof that when you receive it, you're still able to validate as if you had a full copy of the chain. Well, guess what? Once you can do that for Litecoin or for Bitcoin, you can do that for your own cryptocurrency. So it gives you a much more natural way of sharding and breaking your chain up and partitioning your chain up. And that's an active area of research that we have. Right now, because Cardano is new and we don't have enormous demand, and frankly, all cryptocurrencies still live in the domain where we can put them on a single hard drive, it's not something we have to solve today, but it is something that we actually know we have to solve in the future for these systems to be stable, and then something that we have a lot of really good ideas, and there's a lot of great projects floating around the space that have made good progress on it. And it's just a matter of porting them and getting them to work for us, as opposed to reinventing the whole wheel from scratch.
Yeah, so as far as that development goes, it sounds like you've got a lot going on. Your team is kind of known online as having a lot of, really smart people, like real scientists,
right,
working on these problems. So could you talk a little bit about your team?
Yeah, so IOHK as a company is really two companies in one. We have a research company and a development company. On the research side, we actually have personnel embedded in universities. So we have people in University of Edinburgh, University of Tokyo Tech, University of Athens, and so forth. And basically, these guys work with the professors, the graduate students, the postdocs, and they write papers just the way you would write a paper as if you were trying to get tenure at Harvard or something, and submit it to top-tier computer science conferences and go through the proper peer review process. So because we have that facility, which most blockchain companies don't, it's given us access to some of the brightest people in the world. For example, we write all of our software in Haskell for Cardano. Well, we hired one of the guys who created Haskell. And this is one of those things you can do when you have access to the academy. The challenge is that their motivations and timetables and work processes are distinctly different from an engineering company, and so you have to find a way of balancing principles and pragmatism. If you're overly principled, it's perfectly okay to spend 5 or 10 years doing something which may or may not work at the end, and if it doesn't, oh well, we'll do something else. If you're very pragmatic, you have weeks to months to be able to ship a product. So how do you balance these two things so you can kind of get the best of both worlds? And that's what we do at IOHK. We have many, many great Haskell developers. We have many great academics. And if you go to our website, iohk.io/team, you actually can scroll down and see all the different people that work with us. And you can kind of see through our press releases and blogs where and how we're interfacing with the peer review process and the formal methods process. So we're quite proud of the team. People like Agalos Kayasas and Dionysus Zindros and Phil Wadler and others. They've done some really amazing work, and we continue to grow and scale and expand. In fact, tomorrow we're going to make an announcement about a new researcher collaborating with us who's an expert post-quantum crypto to help make Ouroboros resistant to quantum computers. And that connection in the academic world is what makes us unique, in that we can interface with those types of people.
Great. So you just mentioned Ouroboros. Could you talk about, you've been around for a few years now. Could you talk about where in your roadmap you're at, what you've gotten done, what you're still working on, and what we can expect in the next 2 to 3 years?
Sure. With respect to Ouroboros? Because there's a lot.
Yeah, just the platform in general.
Okay, well, I could talk forever about that. So I'll start with Ouroboros and kind of work my way from there. So if you look at proof of stake in general, you have 3 buckets. You have the stuff that's been already deployed and it's working in industry. So those are the NXTs, the Peercoins, the BitShares of the world. And they have all these different flavors. And basically it was all about, can we make a practical system? And hopefully it works. And if there's a problem, we'll iterate our way out of it. Okay, so that's one bucket. And those are tried and true, and there's some empirical evidence that they're reasonable ideas, and at least their sins are known. Then the second bucket are the next generation POS protocols that are being built by industrial actors. So these are the Definities, the Tendermints, the Caspers, the upgrades to DPoS that Dan is doing for EOS. And basically these come from the wisdom that people have learned about existing deployed systems. And then the third bucket are the true academic protocols. So these are the ones where they've kind of slided all that stuff to the side, and they said, we're actually going to go to top distributed systems people and crypto people and try to convince them that we've actually done the job properly. So Snow White, Algorand, and Ouroboros fall in that bucket. Now, there's a big degree of philosophy of which one of these is the right approaches, and probably a hybridization of them is the right way to go. But we've chosen the third bucket mostly because we have access to the people who can do that, and we feel that this is the process most likely to give us a very solid foundation to build up all the infrastructure that we need for our system. At the end of the day, the heart of a cryptocurrency is the consensus algorithm. So if you're a Bitcoin, your heart is proof of work. If you're BitShares, your heart is DPoS. And similarly, Cardano's heart is Ouroboros. So what we wanted to make sure is that the heart of our system was as secure as possible, as modular as possible, and we have the clearest idea of how to upgrade that heart to make it stronger over time and beat faster, and also to have many hearts as opposed to one, so that we can support many different blockchains. So we started the Ouroboros research agenda back in 2016, and we started in a very simple way where we asked, what is a secure ledger? So what are we trying to accomplish? What are we trying to, it's like, if you have a heart, what does your circulatory system look like? So similarly, what does a blockchain actually look like? And so we answered that question. Then we asked, what types of consensus algorithms can actually make that secure? So we started with proof of work, and we showed that, yes, proof of work can create a secure ledger. Good work, Satoshi. Didn't have to prove it. He just got it right on the first try, which was real rare, but a pretty smart guy. And then we said, can proof of stake do the same thing? So are they equivalent to each other? If you go to Blockstream or you go to any of these proof of work companies, they actually say that proof of stake can't work. It's illegitimate. It never can create a secure ledger. So it was a very controversial question of whether proof of work and proof of stake can have the same level of security. From our perspective, given the research we've done and the papers we've published that have gone through peer review, our opinion is that proof of work and proof of stake can create equally secure ledgers. So we've answered that question first. The next set of questions were, how do we make it practical? So how do you get it to live with adaptive corruption in a semi-synchronous environment? And how do you actually make sure the economic incentives are right and so forth? And that's basically where we're at in the development life cycle of Ouroboros. And we're leaving that phase because we've solved most of those problems in our view. And then the next level is interoperability and scalability. So that's Ouroboros Hydra and the sidechains scheme. And the Hydra side of things is saying, let's shard the protocol and run many epochs in parallel so we can get to tens to hundreds of thousands of transactions. That property of as people join, you gain more resources. And interoperability is all about how do we get these chains to talk to each other, and how do we talk to external systems and preserve the security proofs. And that'll be something that we start doing the second half of 2018 as we exit the practicality phase. So really it started with theory and security. We exited that phase and entered the practicality phase, and we're starting to finish that whole research phase off. And then the final phase is the performance phase, which is say, okay, now let's build a system and make it scale to millions to billions of people and talk to lots of different systems.
Great. So I'm a smart contract developer myself. So I'm always really interested in smart contracts. What kind of support do you plan on having for that kind of structure in your system?
Right. So the problem with smart contracts is we don't actually have a good definition of what we mean by a smart contract. So the Bitcoin people say, hey, Bitcoin supported smart contracts since the very beginning. Bitcoin script is technically a smart contract. And then we have the 90s version of smart contracts that Nick Szabo came up with. And then we have the Ethereum style smart contracts. But then there's all these other ideas of smart contracts. So I like taking a smart contract and just putting it aside and saying, okay, what are we actually trying to accomplish here? We have this idea of verified computation, so services effectively. So you have an app where you put an input into it and you want an output back. And under ordinary circumstances, you would run that on a server. Okay, so like an Amazon server, or Rackspace, whatever that may be, and it would give you an answer back. But for some reason, you don't trust that server. Maybe you think you're going to get censored. Maybe you think it's not resilient enough as an architecture. And maybe you think that the answer that they're going to give you back is going to be a lie. Let's say it's a gambling application and they misshuffle the cards so that the server gets an advantage over you. So what Ethereum provides as a system is it's a service layer for verified computation. You send a message, you get a message back, you pay something for that, and you know that as long as the majority of the people in the system are honest, that is going to be awesome and correct. Okay, so from one perspective, that's what we mean by smart contract. From another perspective, we think about things like decentralized applications, and we think about DAOs and these ideas of blockchain-based entities that don't live on servers. Instead, they live in this mesh around the internet, and they're persistent, and they just run and they interact with other systems. And that's a very different view than the verified computation view. Okay, all right. So given that you have these kind of different ontological notions of what is a smart contract, you have to be very specific about what are you going to service and how are you going to accommodate these things. The last thing that you have to think about before you start getting into the smart contract discussion is this a global or is this a private event? Okay, so, do I want code in a contract that everybody in the whole world can see, everybody in the whole world can interact with and send a message to? Or do I want a contract that only I and the people that I've assigned have access to? Like, think of a multi-sig contract. Ordinarily, when you think about multi-sig, you're saying, okay, I have some asset, you have some asset, and Bob has some asset, and we're going to coordinate out of band, construct a transaction, and then submit that transaction to the network. That's normal Bitcoin level of multi-sig. But then you can think of a smart contract that facilitates multi-sig, and that lives on the network, and anybody can send a message to that. Well, that's what happened with parity. And then somebody was clever enough to figure out that there was an issue with it and degrade the security and loot the funds, right? So you have to be very careful about whether this is private or public and who gets to run it and how do you interact with each other. Okay, so that's the preface to all of this. So let's talk about what does Cardano bring to the table? Well, I'm a firm believer that if the market sets standards and people have already invested hard work and resources into something, it's a really bad idea to just spit in their face and say, everything you've done is wrong, go away, you're a horrible human being. You have to give them, a glass of water, even if they're living in hell. So you go out to those guys and you say, all right, we'll be backward compatible with what you've already done. So Cardano will be backward compatible with the Ethereum ecosystem. So if you're a Solidity developer and you love all your tooling, we're going to pull that into our stack and you can just keep using that. And we're going to maintain backward compatibility because that multi-chain model that we have. So it's easy for us to have an Ethereum chain and preserve what they're doing and allow you to stay in that ecosystem. And then our argument is deploy on our system because it's cheaper, it's more secure, it's faster, and so forth. So you as a developer don't have to be loyal to Ether. You can ask yourself, what is the best infrastructure for this job? Second, we'd like to bring new people into the space. So we look at the Java developers and the C# developers and the C++ developers. These guys are the bulk of all programmers. And what Ethereum is doing is saying, throw away everything that you know and you love, and all the tools that you have fun with, and go take our stuff, and one day our stuff will be okay, and we'll have a good experience. All right, but I don't think that's practical or realistic. You have to have a path so that if somebody wants to write a smart contract in Java, they potentially could do that. So we have a chain called Yella that we're building in partnership with Runtime Verification and UIUC, where we're studying how to use the K framework and LLVM and all these other clever things so that we can maximize interoperability and start allowing people to write smart contracts in regular everyday languages that they've come to know and love. And our hope is that that will broaden our developer base above and beyond what Ethereum has already brought into play. Finally, there's this idea of high assurance software. So this is code that can't fail. This is where the code is law people tend to live. So let's say you're a utility. Let's say that you're a jet manufacturer. Let's say that you're building aerospace software for rockets or something. If you screw that up, the power goes out and the hospital no longer has energy, or grandma freezes to death. If you screw that out, the plane falls out of the sky. If you screw that up, the rocket explodes. There are certain types of software where you can only write it once. And if you get it wrong, the consequences are very bad, and you can't move fast and break things. So smart contracts are no different. These are small programs that have a lot of money behind them, a lot of users behind them. And if you screw up your multi-sig contract, that's bad news for a lot of people. So it's important that you give people a sandbox where they have the highest probability of writing correct software at the expense of accessibility and at the expense of ease of writing. So one is borrow from the past, one is maximize interoperability, and one is high assurance software first, right, get it right, it's code is law. Okay, so we're going to do all three of those with the public smart contract stuff, and they'll just be different chains. And we can run them in parallel with SL. Now, that's for the on-chain stuff. Then what we're going to do with Cardano is bring a lot of off-chain stuff into play. In particular, there's two areas that we're super duper excited about, and we just really want to bring into space. We think are going to be amazing. So one is multi-party computation. The other is trusted hardware. So with respect to multi-party computation, the easiest way of understanding this is, let's say that you want to do a shared computation with everybody within a business or within a group. So the canonical example is you want to figure out what the average salary of everybody who's working at a company is. Okay, well, you could do that naively where you say, Bob, I trust you. You're going to go do this calculation. And Bob's going to add everybody's salary up and divide it by the amount of people and say the average salary is $50,000. The problem is that there's knowledge transfer there. If Bob does that calculation, now Bob knows how much you make, how much I make, and everybody else, and Bob can tell everybody in the organization. So the purpose of multi-party computation is to do problems like this, collective problems, whether that be gaming and gambling, decentralized exchange, whatever have you, where each person does not reveal their personal knowledge, but yet you can get the output of the aggregate calculation. So like with poker, we're playing a game together. I don't want to reveal my cards to you, but we still need to figure out who's won the round, right? So we wrote a protocol for that called Kaleidoscope. And we are building a whole bunch of other protocols for this. And what this allows us to do is to do off-chain computation. So you run the MPC circuit off the blockchain and use the blockchain as a trusted bulletin board. So you post some data to it and use the blockchain as a coordination layer so we can use it to find each other, because if I want to game against you, we have to match, we have to find each other. But then once that's done, all that stuff is out of band, low latency. It can be done in synchronous with the main network, and we use the blockchain to settle. So you get your winnings or your losses. Pretty simple, right? Well, that's great because that scales, because the resources to run that kind of stuff come from the players themselves, from the people themselves. So one direction is bring multi-party computation into Cardano. The other direction is we have these things in our phones called trusted hardware, and they're in your computer. If you're using an Intel laptop, you have SGX in your system. And trusted hardware is hardware that can't lie. So when you tell it to do something, you can't, once it's told to do it, tell it not to, or tell it to do something else. It's just going to do it. It's like Fantasia with Mickey, and he animates the broomsticks, and they just go about and do their thing. And no matter what he can do, he can't stop them, right? They're just automatons. They're doing their thing. So the magic of trusted hardware is that you can now trust hardware to do things that you wouldn't trust people to do. So for example, my favorite example is offline off-chain payments. So what if you could construct a special address that you get a guarantee that's the only copy of that address in the entire world, only lives on that phone or only lives on that laptop, and then you send some crypto to it. And then what if you want a transaction system where I can, over Bluetooth, move that from one trusted hardware enclave to another trusted hardware enclave? And if that movement's confirmed, it destroys the address on my computer, and that person I've moved it to has the only copy. Well, guess what? From the blockchain's perspective, no transaction has happened. You've just moved a private key from one device to another device. So that transaction settles off network. It doesn't require you to have an internet connection, and it can be done anywhere in the world. And it's totally anonymous because there's no forensics to analyze. You don't even know that the key's been moved, right? You'd have to actually capture the devices and break open the trusted hardware and use sophisticated tools to try to figure out that something has happened there. Well, so that capability is currently outside of the cryptocurrency space, but Intel and ARM and AMD and other manufacturers are building these things. And we're even building them with trusted hardware wallets, right? You have ledger devices and so forth, and they have these HSMs within them. So my point is, let's build some libraries so that people can bring these types of protocols in, and now we can use them to execute smart contracts off-chain, and we can use them to do offline off-chain payments, and we can use them to do state channels and side channels, state channels and payment channels in a way that is much faster than if we were to try to do this in software, and in many cases preserving your privacy as long as you trust the trusted hardware. So that's the other side of Cardano. It's like, one is be very pragmatic and allow us to have interoperabilities with come before and interoperability with existing languages which aren't currently in the space and have a lot of principles, but then bring new capabilities in like MPC and trusted hardware, and that constitutes our smart contract stack. Now, this has to be done systematically and gradually. So the project that will roll out the first generation of these things is called Goguen. And the later generations of that will bring in these cryptographic capabilities for MPC and these capabilities for trusted hardware. And then it's just a matter of a back and forth between us and the community. And as they need things, we build things, and we keep adding things into it via our partnerships. So that's Cardano's smart contract notion.
Yeah, that's going to be pretty amazing. That's something that's sorely lacking in the blockchain space right now, is this kind of interoperability. So for my final question for you, I'm going to get a little bit personal. I'm hoping you can tell us a bit about your own personal background, what you did before Cardano, and what brought you to the blockchain space in general.
Right. Okay, so I never thought I was going to be a cryptocurrency entrepreneur. I was a mathematician, and I enjoyed teaching, and I figured if anything I did in industry, maybe I'd do data science or something, or contract programming, and I even did a little of that. But I never intended to be an entrepreneur. It's running a company is really hard, and I'm not a very nice person, and some people like me, some people don't like me. So I figured I didn't have the temperament or the strategic vision to be able to run these types of things. So like all great entrepreneurs, I accidentally stumbled my way into the cryptocurrency space, into being an entrepreneur. And it started with education. I started with something called the Bitcoin Education Project. And basically, I just created free educational material for cryptocurrencies. I said, this is what Bitcoin is, and I make some YouTube videos. And then eventually I created a Udemy course, and it was very popular. I had over 70,000 students. And that gave me the opportunity to kind of meet, at the time, all the people in the cryptocurrency space, the Eric Voorheeses and the Roger Vers and the Andreas Antonopouloses and so forth. And that bootstrapped me to a point where I had capital to start a company. So I said, all right, well, somebody's willing to give me some money to be an entrepreneur. I mean, I'll give them the disclaimer that they're probably going to lose everything and I'm going to fail miserably. And in 6 months, I'll be back in mathematics. But as long as they're okay with that and they know that's the most likely outcome, I'll certainly take the risk. So I did. I created a company called Invictus Innovations with Dan Larimer, and Dan and I helped create BitShares. And then from there, I moved on to help create Ethereum with Vitalik Buterin. And then after Ethereum, I moved on, and I was in a position where I could be very principled about what I wanted to do. So I created a company called Input Output, where we had both a research division and an engineering division, and I could do the types of things that I wanted to do. And what our company does is we construct cryptocurrencies for a living. So we do everything from the kind of the pre-work of why are we actually doing this? What's the existential purpose of the cryptocurrency? What problems is it trying to solve? To the nuts and bolts of the research, to the actual nitty-gritty of the implementation and deployment into market, and making sure that it's handled correctly. And so we started with 2 people. It was my co-founder and I, and back in 2015, and now we're about 100 people, and we operate in about 10 countries, and I travel about 200 days a year, 250 days a year. I've been to almost 40 countries, I think, in the last 2.5 years. It's been a hell of a ride.
Yeah, that sounds like it. Well, on that note, it sounds like you're a very, very busy person. So I will let you go. Thank you so much for spending a half hour with us. Really appreciate it in the Cardano projects.
Thank you so much. This was a heck of a lot of fun. I'll talk to you soon. Cheers.